Hi, we briefly discussed the power series and how to apply power series to approximate an interest rate. Okay, so theorem. So this is just the examples of Taylor expansion. So it should be covered in the Math 2020. So we don't use the Taylor expansion heavily, but at least it's useful to remember that the exponential of x is approximated by this series, the 1 plus x over 1 factorial, x square over the 2 factorial, x cube over 3 factorial, and so on. So remember that the factorial, for example, the 3 factorial is 3 times 2 times 1. And also the log of 1 plus x. So this is x minus x squared over 2 plus x cubed over 3 minus x fourth power over 4. So just the sign is alternative. So negative, positive, negative, positive. And you have to be careful that the denominator is just the 2, 3, 4, not the factorial. So these are useful to calculate some rates. So for example, the last time that we discussed the delta when I is equal to 0.05, but the delta is equal to 1 plus I. So delta is cost of interest, corresponds to effective rate of I. So, okay, so log of 1 plus I that you cannot calculate by hand, but this is actually approximated by I minus I squared over 2 plus the I cube over 3 minus and so on. Maybe I cube fourth power 4 plus and so on. Okay, so I is small number. So I is, for example, 5%. So I square, I cube, I to the fourth power, it gets smaller and smaller. So the later terms that don't affect the result much. So if I is equal to 0.5, okay, so when we use the first term, of this, so delta is approximately I. So that is kind of obvious and the rough approximation. So delta is equal to, okay, so I, so this is equal to 0.05. But if we use the first and the second term, then delta is approximately equal to I minus I square over 2. So that is 0.05 minus 0.05 square over 2. So this is 0.02. So 0.0025 divided by 2. And so that is the 0.00125. Okay, so this is approximately, actually, this is equal to the 0.4875, right? So 1, 2, 2, oh, maybe not, 0.00125, so 0.4875, yes. So if we use okay, so first to third terms, then delta is approximately equal to I minus I square over 2 plus I cube over 3. So this is actually equal to 0.05, maybe just the first 2 terms are the same as the last time, but we have another term. So 0.05 cube over 3. So this is equal to actually the 0.04877, so 0.0488. So this is almost the same as the exact value of delta. So if we use this approximation, then you can get almost the exact answer. So this is useful to approximate an interest rate, especially since this actuarial exam is multiple choice exam. So make a good estimate that is key in the exam.